Hi, in this video we'll be talking about passing arguments to functions in Python. Arguments are passed by assignment in Python. The objects passed as arguments are assigned to the names used as parameters in the function definition. Here's a very basic example. We have a function definition, func, with two parameters a, b, and now let's use this function like so. X equals func 5, 10. So here the two integer objects passed as arguments 5 and 10 are assigned to the two names used as parameters in the function definition, a and b. So this is how we pass arguments to a function in the most basic scenario. We call such arguments positional arguments because they are assigned to the parameter names by position. The first argument is assigned to the first parameter. The second argument is assigned to the second parameter, and so on. Well, here we have just two parameters, but if there are lots of parameters in a function definition, it's very easy to lose track of them all and omit one or more arguments in the function call, which leads to wrong assignments and errors. Besides, sometimes we don't know how many arguments will be needed. Suppose we want to make a function that can take any number of numeric parameters and calculate the average of them. With just positional arguments, it would be impossible. Fortunately, there are a couple of other argument matching modes in Python. Let's have a look at them now. Here's a short overview before we dive deeper into the details. We have the following argument types at our disposal. Positional arguments, matched from left to right. Keyword arguments, matched by name. Default arguments, assign default values if omitted in the function call. Star arguments, iterables unpacked into individual positional arguments. And Doublestore arguments. These are dictionaries unpacked into individual keyword arguments. And now let's discuss them one by one. We already discussed the positional arguments, so let's now have a look at keyword arguments. Keyword arguments are passed by name. They can be passed in any order. Here's an example. Here we have a simple function with three parameters, name, age, and city, and this function just prints them out. We can now pass the arguments in the following order. Name equals Jack, age equals 38, city equals Sacramento. So these are the keyword arguments. We use the keyword, which is the name of the parameter from the definition. But we can also use a different order, because here the order doesn't matter. For example, we could use the function like so. Age, then name, then city. Or in yet another order like this. City, then age, then name. It's all the same actually. So as long as we pass the arguments by name, the order doesn't matter. There may be also both positional and keyword arguments in the function call. Then we have to pass all the positional arguments first, in the same order as the parameters in the function definition, and then we can pass the keyword arguments in any order. Here's an example. So here the first two arguments are passed by position, 2 and 4, and they are assigned to a and b respectively. The other three are passed by name, so they can be passed in any order. We have E, then C, then D, but it could also be C, D, E, or anything like that. The order doesn't matter. Next, we have default arguments. These are arguments that are optional in the function call. If we pass them to the function, they work as any other arguments. If we don't pass them, they take default values specified in the function definition. Here's an example. This is our function. The first parameter wasn't assigned a default value in the function definition, so it's a mandatory parameter. and we must pass at least one argument to the function that will be assigned to it. If we pass just one argument, then b and c will be used with their default values of 10 and 3. So let's use the function like this, func with 5, one argument only. And we get 18 because the function returns the sum of these 3 arguments. And now a was assigned 5, and the values of b and c are the default values 10 and 3. 5 plus 10 plus 3 equals 18. Now, if we pass 2 arguments, then the second one will override the default value of b, and the value of c will be still the default value of 3. So, func 5 and 4. Now, this argument will be assigned to a. This argument will be assigned to b and will override this value. But as we don't have a third argument here, then the default value of c will be taken. So 12. It's 5 plus 4 plus 3. If we pass all 3 arguments, the default values of b and c will be overridden. So func 5, 4, 6, 15. So now 5 is assigned to a, 4 is assigned to b, 6 is assigned to c. 4 and 6 override 10 and 3 respectively. Now, if there are both positional and optional parameters in the function definition, the positional ones must come first, just like in this example here. If there are multiple optional parameters, we can use default arguments as positional or keyword arguments. Here's an example with default positional arguments. Now, the 2 first arguments are mandatory because they are not assigned default values, but all the rest have default values. So let's call this function with 2 arguments, func 10 and 10. The result is 35 because the function actually just sums all the arguments up. And as we have 10 and 10, then it means that all the default values from C to G should be used. Now, suppose we want to use all these default values except the last one. Here, we want to pass 20. G should be equal to 20. Unfortunately, with positional arguments, we would still have to pass all the default values of all the arguments that precede G. So, if we want to change this to 20 and maintain all these arguments, we would have to call the function like so, func. Now, here are the values for A and B, and then we would have to repeat all the values before the element that we want to change. So, it's 1, 2, 3, 4, and then we can pass the new value for G, 20. Okay, but we can easily get around it using keyword arguments. So, func 10, 10. Now the point is that we don't want to change these values. We only want to change this one. So here we had to repeat the values anyway, but using keyword arguments, it's no longer necessary. So we can just pass G equals 20. And now all the other default values are maintained. Now, the next type of arguments are star arguments. The star notation can be used either in the function definition or in the function call. We use the star notation in a function definition if we want our function to be able to take an arbitrary number of positional arguments. All the arguments will be packed in a tuple. Here we have an example. Here is our star argument. And this means we can now call our function with any number of arguments, including 0. So let's call the function with 0 arguments. Func. What we get is actually nothing, because there aren't any arguments. What the function is supposed to do is it should print the following text: an arrow like this and the argument. So now let's pass one argument. Func 1. And here is what we get. Arrow 1. Now let's pass 5 arguments. 1, 2, 3, 4, 5. And this is what we get. Now we use the star notation in a function call to unpack positional arguments. Here's an example. This function takes 5 parameters, and this is what it returns. And here we have a list of numbers. For example, 5, 4, 3, 2, and 1. So this is a list. So if we pass this list as an argument to this function, there'll be a problem because it needs 5 arguments and we'll pass just one, the list. So what we have to do is unpack the elements from the list, which are 5, into individual objects. And we can do it using star notation. So let's now unpack the list into the 5 individual arguments required by the function. Func star nums list. And now it works. Finally, we have the Doublestore arguments. They work just like the star arguments, but for keyword arguments. So again, if we use the Doublestore notation in the function definition, we can pass an arbitrary number of keyword arguments, which will be packed in a dictionary. Have a look. Here we have a function. Here we have a Doublestore argument, which means we can use any number of keyword arguments. And this function just takes the arguments and prints them in this form. Now we can pass any number of keyword arguments, including 0. So let's do it. Func. And we get nothing. Now let's pass one keyword argument. Func name equals Alice. And this is what we get. And now let's pass 5 arguments. Name equals Alice, age equals 74, city equals Rome, hobby equals knitting, pet equals rat. And this is what we get. Now we use the Doublestore notation in a function call to unpack keyword arguments. Here's an example. We have a function that needs 4 arguments. It just prints the arguments like this. And here we have a dictionary where the keys are the names of the parameters in the function definition, A, B, C, D. The values are French numerals. Now again, this function requires 4 arguments, so we can't pass the whole dictionary because it would count as one argument. But we can unpack these into individual arguments. We can do it like so. Func Doublestore French numerals, and this is what we get. In order not to overcomplicate things, I will cut the video here, but I'll make some more videos on passing arguments to functions soon, so stay tuned. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.